Okay, so this is a relatively simple panel. Power on brings the light on here, and then this switch here changes whether two dampers are open or closed. So in that position, one will be open, one will be closed, and in that position, the opposite will happen. I'm going to start wiring this, working to this drawing. So this is the mains bit done. L1 neutral going into the door isolator, and then L1 to Q1, the MCB, and then out of the MCB into the power supply, and then it's pretty much the same with the neutral, just straight into the power supply. In here, L1 and neutrals straight there. L1 is going into the top of the breaker, out the bottom of the breaker, L11 into the power supply, and then earth is just similar to the neutral. Right, so the next bit's going to be the 24 volt DC out the other end of the power supply, and 0 volts, that's just going to go to a little buzz bar, and the 24 volts is going to go through a fuse and then again to the buzz bar, little buzz bar that I made up, and then from there we start connecting up the other bits. So 0, 1, that's going into the fuse, and then 1 is going into that buzz bar, and the same thing with the 0 volts. And the other 0 volts, I'm just leaving a tail for something. So the first bit's really simple. That's just the white lamp power on, so telling us that that power supply is working. That just goes across the power supply, the 24 volts and the 0 volts, so that will light up when that is on. So that's what we'll do first. This is for the lamp, so we got a 0 volts and a 24 volts, and that's just going through the trunking up here, and then I've just roughly made a length that's going to go up the side of the box and over here when I put the panel in. So that's going to be for that. That 24 volt lead is also going to feed that select switch, and the 0 volts is doing obviously the lamp and the red trip lamp. So the next bit is going to be the output of this switch, which is the manual control determining which damper is open and which one's closed, and vice versa. So that will just energize that relay, which energizes these. And we've also got an optional output from the customer's PLC. I don't know whether this is going to be used. This was added in at a later date, but it's an option there. And I've just realized probably a good idea to have a 0 volts being common from the customer's PLC power supply and the 0 volts of this power supply, just in case there's any potential difference that could cause an issue. So yeah, they're basically being commoned up. That's the next bit done. So cable 2 splitting off 3 ways out of the switch, terminal block 5 and A1 of the relay. So the switch, that's there, which will be going there, going to terminal 5 and then doubled up and going to relay 1, A1. So the next bit, we are going to come out of the buzz bar, cable 1, 24 volts feeding the top of Q2, which is that, and then out of Q2 into contact 12 of relay 2. Next bit is just going to be that cable from 11 on relay 2 to the lamp, which is obviously just going to be a long tail for now, similar to the rest. Okay, on the other end of this Q2 means power is allowed to flow to these 2 motors. So if that switch isn't closed, that relay isn't energized, which means that this just stays in its normal state. So power comes down here through these A and B, back through these 2 terminal block to 0 volts. Then if this switch is energized, let's say that position, that energizes this relay, which flicks these holes on the relay across, which then means the power will flow this way and then across there to 0 volts. So it's just a way of reversing the way the motors run for A and B, and the polarity on these are different, so they work the opposite way round. So that's all the relay logic done now. Yeah, can't really see much, but just lots of cables. So the final things to do really are the 0 volts that haven't been done yet, and wiring up the door with these tails. So that's all the 0 volts done, and the panel basically finished. So the only remaining thing now is to test the panel and put some labels on the front to indicate what these are doing. This is a relatively low budget panel, so we're just going to put a label machine sticker on there. Right, so here we are with the testing. That's the test cable, and now let's turn it on. Breakers on, power supply's on. So we haven't got our power light on, but we got our trip light, which means that's popped. So if we push that in, that's as it should be. Popped, not popped, but there's a problem with the power light, and what I can see is it's actually a 230 volt AC light rather than 24 volt AC DC light. So yeah, there's not enough, or not the correct voltage for that light, so I need to change that. Right, that's a 24 volt DC light. So let's try again. Power, that's better. Right, on to wiring in the actuators for the dampers. So terminal 1 and 4 for damper B, and 2 and 3 for damper A. Taking note of the polarity. So that's what I'm going to do now, wire that in. Right, so they are wired in. As you can see, I just fired it up and one's gone out and one's gone in. That's in the B position. If I go A, okay, and then if the fuse pops, got that red trip light. So the final test is going to mimic this customer PLC output to override this switch, and I'm just going to use a 24 volt power supply. The 0 volts is already connected. So let's try it with B to start with, even though it says A setting for PLC control. So the 0 volts is in there, and then if I put that, nothing happens. And if I select A, so we put those back to that position. And then if I do this now, so yeah, that's mimicking the output from the customer's PLC. Now it's just a matter of modifying the drawing to reflect these changes, and that's job done. That's the bits, the drawing in the panel, ready to go out.